Hello and welcome to this meetup session on getting started with Starburst. I'm Mudit Khitan. I'm a Starburst certified instructor. So let us start with our agenda for the day. So first of all, let me introduce the company that I represent. DataCouch is an international leader in training the professionals, and we have established our leadership in enterprise IT training in B2B segment. And we are now moving on to the B2C segment as well. We are also a consulting partner for many Fortune 500 companies for various IT services. We have a unique browser-based lab solution that we offer to our clients for their internal L&D purposes, for training purposes, and to offer it as a sandbox or a demonstration tool for the requirements of small and medium-sized companies. We are also offering managed services, especially in the areas and domains of IT training and augmenting the IT staff in leading edge technologies at various companies. As you can see that there are many domains that are associated with Web3 that are listed on the screen. So these are some of the top domains that we are working in, but there are many more. And these include domains such as generative AI, drone technology, AR, VR, cloud, DevOps, agile, blockchain and NFTs, automated testing, streaming analytics, data engineering, and many more. Now, talking about the footprints, as you can see that almost on every continent we have delivered trainings, and we are presently headquartered in India. We have offices in Malaysia as well as Canada. And as you can see that our footprints are truly global. And this is because of the highly skilled instructors who are flexible to give training across any timeline. So in the 7 years of our existence, in the mere 7 years of our existence, we have transformed 150,000, more than 150,000 professionals in many Fortune 500 companies. There are broadly 75 different technologies that we offer trainings in, which cover 100 plus specific domains and 200 plus certifications. As I told you earlier, we are focused upon Web3 technologies, generative AI, big data, DevOps, cloud, agile, and so on. And the instructors team that we are quite proud of include industry experts who are globally renowned professionals and who are certified by tech giants such as Google, AWS, Microsoft, Confluent, Starburst, and so on. Our footprints, when we talk about our footprints, it may include our trained professionals are working in these companies. It may include the companies that we have directly partnered with, or the companies for which we have delivered training as their education partner or resource partner. So our footprint can be found in giants in every sector and domain. So when it comes to, let's say, technology giants, we have companies such as Neo4j, Infosys, Accenture, TCS, Apple, PayPal, Microsoft, Google, and so on, for which we have given these services. When it comes to financial services, you can see companies such as PayPal, Manulife, Visa, Verizon, and UBS Bank or Deutsche Bank, and so on. When it comes to pure play IT companies, we have delivered trainings for Cisco or Apple or Microsoft, and so on, and Google. So not only we are present in different domains, we are also present in different industry verticals. And these include many, many companies and Fortune 500 list of the world. We are actually excited about sharing our knowledge with community, and that is why there are two meetup groups, that is AI Minds, which is the hub for AI intellectuals, and there is another group that is called All Things Data, that is the group for data enthusiasts, data engineers, data scientists, data analysts. There are 10,000 more members globally, and every month we try to organize 1 to 2 meetups and live sessions like this one. So we have conducted more than 100 live sessions in the past 2 years only, and we have covered more than 50 technologies and specific topics in those sessions. Because of the excellent services of our instructors and because of the excellent services of the team DataCouch, Confluent has chosen DataCouch as the only global education partner for the year 2022. So that was a very big achievement of DataCouch for the past year. And this year also, we want to achieve this feat second year in the row. We were also recognized by CIO Insider, a reputed magazine, as one of the most recommended AI startups for the year 2021. Because of our strong pedigree and our commitment to excellence, Starburst which is the focus of this meetup session, chose us as their first global education delivery partner. So we are quite proud and honored by the recognition conferred upon us by industry giants like Confluent and Starburst. About me, so I have 20 years of industry and academic experience, and I've worked in multiple domains that includes big data analytics, development, and robotic process automation. I presently work as principal consultant at DataCouch. I've delivered trainings, highly rated trainings for Walmart, J&J, Barclays, and many other companies for DataCouch. And in my free time, I would like to study and practice more about value investing and human psychology, which are both quite data-driven and insight-driven, to say so. Finally, let us come to the agenda before we begin the session. So in this meetup session, we are going to cover evolution of data platforms and the problems with the current data platforms or the current data scenario that is there. Then we are going to see why there is a need for a federated SQL engine and how a massively parallel processing query processing paradigm or MPP query engine can solve the problems that are there. Then we are going to see why simply having an MPP query engine is not enough and how Starburst can add value to that MPP query engine and how Starburst can become your not only data pipeline, but also your analytical query engine or DLAP, that is data lake analytics platform. We are going to conclude this event with a demonstration, a hands-on demonstration of Starburst Galaxy, the cloud native platform of Starburst Data. And I would urge you to ask your questions, to park your questions in chat. And as we progress in the demonstration, as we progress in the presentation, I'm going to take up those questions and I'm going to answer them from time to time. If you have any question, you can raise your hand and the moderator of this session would unmute you and you can ask your questions directly also. So with that, let us start with the session. Okay. So a typical data pipeline looks like that we have raw data coming in from different sources. It can be structured, semi-structured, or unstructured data. And this raw data is processed, transformed, and it is taken for analysis. And once we get the data analyzed, we derive insights and conclusions from this raw data. The problem with this typical approach or the conventional data pipeline are many. Let us see what are the problems that most of the data engineering teams are facing with this typical data pipeline. The first problem is of data is in silos. Whatever data pipeline you have, there are still many pieces, there are still many data sources, and there are still many sections in the data pipeline that are not connected with the well-oiled plumbing. And these data sources remain in a silo. And whenever you want to perform some kind of data transformation, data migration, or any kind of ETL job, you have to run a batch job, you have to run a separate job for them. And then it has to be taken out and synchronized in an offline manner, and it cannot be done online. So, for example, if there is a legacy system that is there in the organization for last 15, 20 years, and there is a modern cloud-based system, it is quite difficult to integrate both of them into a single data pipeline because both of them present a different set of challenges. And because of that, the data remains in silos. So it is not possible that a single data pipeline is able to connect both these legacy and modern systems. That is one of the challenges that most of the engineering teams face. The second problem is the complexity and scalability. As you can understand, the data is changing every day. The formats are changing. The data requirements are changing. The teams, the business users of the data, their requirements are changing, as well as the technical requirements that are required for processing the data, that are required for collecting and analyzing the data. They are also changing. And with that also comes the issue of scalability that adds its own complexities. So even if we look at only 2 years or 3 years before, just before the pandemic hit, the amount of data being processed by the systems was quite low. But as the world was locked down and everybody moved online, within a span of few weeks, the amount of data that these systems had to process jumped manyfold. So the systems which were scaled, the systems which were able to scale to this requirement were able to take advantage of these system opportunity. And those systems that failed to scale left out, and they lost the market share very significantly. The next problem is the flexibility of current systems is quite limited. For example, some systems are geared to process a bulk of data that is coming into them, and that bulk of data can be in any format. These are typical data lakes. Some other systems have been fine-tuned to process structured data, and that structured for processing and transforming that structured data, extracting that structured data is quite easy for those systems because they have been fine-tuned for that particular use case. For example, data warehouses. Some systems have been designed to build processes which are more user-friendly, some processes which are sometimes more analytics-friendly, but it is a problem that there is no flexibility. If you have a specific cloud vendor, if you have a specific data provider, then there is also a problem that you have been locked in by that vendor, and you can only access tools and you can only make use of the tools that are compatible with that specific vendor. It again reduces the flexibility that your teams may require to compete in the current scenario. Then the problem related to data quality comes in. Data quality problems can relate to its veracity. Data quality problems can relate to its authenticity, its governance related issues. Then there are security issues. Then there are privacy issues. So many issues are related to data quality. Data lineage is another issue, which is directly related to compliance as well as governance issues. So these problems also affect data engineering pipelines. And this once again comes from the data being siloed in different systems, which are not directly communicating through a common data pipeline, a central data pipeline. So that is another issue, because every time you want to process data, you have to bring data from one system to another system. And if there is any transformation that is happening, then the problem is that the lineage may get disrupted. The trail may get lost, and this may put up a question mark on the quality of the data that your system is processing. Then comes the problem of data consistency. Once again, when we are talking about unstructured data or semi-structured data, and it is being processed in connection with the structured data, the problem of consistency comes, right? Finally, all these problems require too much cost to be invested, too much amount to be invested by the companies, organizations, and these are very resource intensive. And when it comes to resource, we are not only talking about the compute or the storage resources, we are also talking about the resources that are related to the human sector of the data engineering teams. Far too many people are today employed in gearing the system, fine-tuning the system, to manage the system, to maintain the system, rather than doing anything productive or creative. Because the data pipeline is so broken, or sometimes the data pipeline is so problematic, there are too many moving parts, and those two parts are not optimized to work with each other. It requires far too many people to actually make them work together so that the system does not collapse. So that is another issue that comes into the picture when it comes to the typical data pipeline that we see today. The point is, do we have a solution for this? And this session is actually trying to give an answer to that particular problem. Moving on. Before we move on to the solution that we have to offer, let us first of all look at the evolution of data platforms. So as I discussed earlier, we had first at the beginning, we had data warehouses, which were fine-tuned, which were optimized for structured data. They evolved directly from RDBMSs. The problem with RDBMSs was that they were not efficient to process data, which went beyond, let's say, gigabyte scale. And data warehouse could process data in terabyte scale. So they were great for querying and aggregating structured data. They were not basically transactional systems like RDBMSs, but they were more historical systems in which archival data would be stored and processed and analyzed and queried at scale. So initially the systems, the data warehouses were patchwork of disparate systems. Then more consolidated data warehouses came into picture. They were difficult to maintain and access. And we are talking about evolution, so we are talking about early 2000s and so on. So they were difficult to maintain and access. It was required by the organizations, by the teams to mostly install these data warehouses on-prem. And they were quite slow because of the technological issues, whether it was related to hardware or the software side of the solution. As these problems continue and the evolution in the cloud industry also happened, so these data warehouses moved to cloud, and then somebody thought of that, okay, instead of only having structured data, why not we have semi-structured and unstructured data, because by mid of 2005 and specifically after the introduction of smartphones in near 2010, the data that was being generated actually exploded, and if that data were not tapped by the companies, then they missed out on a very great resource for insights. So data lakes evolved as a solution to these problems, and they were evolved to store and analyze vast and diverse data types into distributed systems such as HDFS for scalability issues. But there were still problems associated with data lakes. So they were still working on a monolithic architecture, although they moved to clouds later on, but the problems remain there. They were closed ecosystems, and there was a vendor lock-in with most of the data lake solutions that were being offered. And moreover, they were very expensive to scale, and it was very difficult to transition from a data warehouse-based strategy to a data lake strategy. Another problem that came with data lakes was that the people or the data engineering teams who were used to working with data warehouses, they were used to working with tools such as SQL and schemas, which were structured in nature, which allowed for fast indexing and fast querying of data. With data lake, because the data was so diverse, so dispersed, it became almost impossible for them to make use of the same tools. So the problems still persisted. As a solution of these two, a modern platform that is called Data Lakehouse came into being. It is a hybrid of data warehouses as well as data lakes. So you can think of a data warehouse as a dam, as a reservoir, large reservoir, where not only that water that is coming from raw sources, from different sources comes in, which is unclean, impure, but it is impure in the sense that this data, this water cannot be consumed directly, especially for human drinking and so on. But this data or this water that is coming in is pure in the sense that it is not touched by anything. It is directly from its natural source. But along with that large reservoir, that large dam, there is a filtration plant associated with it, and that filtration plant has access to every aspect or every part of that reservoir, and it can get data from that particular reservoir at any given time. It can filter that data, and it can transport that data through a system of canals or tubes or pipelines to the human consumers or to the business users to consume it. So it was a hybrid system of data lakes and data warehouses in which there is lots and lots of data in different and diverse formats, but it is also possible to index and query this data very efficiently. So we get the best of both the worlds, and it became for the first time possible to actually have a single source of truth that allowed for processing every type of data that an organization can get it inside. All right. Okay, so if you have any questions, we can park those questions until after the demonstration. And if you think that your question is still very urgent, I would be ready to take it in. So you can type in your questions in the Zoom chat. All right. Okay, thank you. Now, let us dive a little bit more into the concept of data lakehouse. So as you can see in the picture, it is a hybrid of data lakes as well as data warehouses. It is a data platform. It allows for metadata management. It is basically on cloud. It is not on-prem, but it does not mean that it cannot accommodate on-prem data systems. Obviously, it can accommodate on-prem data systems, and it allows schema enforcement on its data. So data can be stored in its raw format, whether it is structured, unstructured, or semi-structured. But it can always be tagged and organized, such as data which is stored in a library. Therefore, it becomes easy to find and understand the required information wherever it is. So the filtration plant has access to different sections of the reservoir, and whenever some new data is coming in, that information that a new data set has come into the data lake or to the data lake house, that gets updated in the central filtration plant, which is essentially your data warehouse. Then there are the advanced tools and technologies for processing and analyzing the data quickly. That is your filtration system of the data warehouse. And it can make use of the stored data to learn new things so that the data storage and discovery can be optimized further. All right. Now, when we talk about the modern data scenario and the need for a federated SQL engine, let us understand it from a different perspective. So when you see that there is global federated access to data sources beyond the data lake, so you see a data lake house, and there are thousands of service providers all across the domain in which they are providing different kinds of services, whether it is SQL databases, whether it is no SQL databases, whether it is data warehouses, whether it is data lakes or data lake houses. So you require a facility, or you require a system that can process each and every one of those data sources as a single point of your contact. It can act as a single point of contact for this thing. So you have, in the form of Trino, a massively parallel processing query engine. And this MPP query engine, Trino, allows you to run federated queries. So when I say federated queries, it basically means a query can be divided into multiple data sources. As a user of this engine, as a developer, I see only one single system. I do not see multiple things. When we talk about it at a user level, from a user's point of view, I run a query simply giving the addresses of different stores, of data stores. And it is the responsibility of Trino to actually divide that query into such a manner so that it runs on different data sources. It fetches me the required results and gives me a combined result from all these things. So as a user, as a developer, as a data engineer, it becomes far more easier for me to run those queries on a Trino rather than running those queries separately on different systems and then combining the results manually. Now, Trino provides us the optionality. Trino provides us the flexibility to use any popular open table formats. It has full support for Iceberg. It has full support for Delta Lake. It has full support for Apache Hudi. It provides us open file formats, which includes Avro, ORC, and Parquet. And it can use any of the commonly used global storage systems and compute systems, whether it is from Google, whether it is from AWS, whether it is from Azure. So whether it is elastic compute services, whether it is object storage services, there is no lock-in for any of the users. So it provides you a single point of access and governance for all of your data, whether it is your on-prem legacy databases, whether it is your on-cloud data warehouses, whether it is your data lakes, whether it is your data lake. It does not matter where your data resides, Trino can access it. You just need to have a proper connector to connect your database or to your data source to the Trino query engine. There are advanced warehouse-like capabilities because of these open table formats. And these table formats allow not only structured data to be processed properly to enforce a schema on that, but they also enforce a schema on unstructured or semi-structured data. It is completely vendor agnostic in the sense that it gives you 100% optionality of moving from any vendor to any other vendor. It means, for example, right now, if you're using AWS buckets to store your data, it does not mean that you are tied to AWS. You can always move on to GCP. Finally, it is scalable and cost-effective. So Trino is that MPP query engine that provides you this optionality. And it actually breaks the silos of the data silos for the first time. Right. Now, let us take a very simple case study when we talk about federated query engines, when we say MPP, that is massively parallel processing query engine. So what is meant by MPP query engine? Let us take it with an example. Let's say we want to process order records on the data lake with a schema of read table referencing. Right. So let's assume that the total data size is only 20 GB. It's not very big, but it is going to help us understand how we can improve our data processing and data analytics requirements. The average record size is 500 bytes. So that is approximately 40 million log records. And let us say that the single processing engine, the single source of your computation, it can process 10,000 records per second is the processing speed. So even if the processing engine, which is having a single core, can process 10,000 records per second, it is going to take almost 4,000 seconds or more than 1 hour to process all these records. So this is your traditional model single instruction computing system, right? So there is only a single core that is processing all the records. But if it is possible to actually divide this query into multiple partitions, into multiple cores which are going to process this in parallel, if it is possible to scan the data in parallel, if it is possible to process the data in parallel, whatever the different stages of your query are, then we can speed up the work very, very efficiently. Let us see how it is done. So parallel processing comes to our rescue in the sense that parallelization divides a single workload into independent units running concurrently. So to process efficiently, in the previous example, continuing with the previous example, imagine that you have the same 20 GB of data as before. Now, instead of processing it through a single processor or compute engine, you can divide your work into equal parts. And let's say the number of divisions are 200. So it is going to actually give you a 20-second per split execution time. So instead of 4,000 seconds, only 20 seconds per split would be there. So you can see that a simple division of work, and we are talking about a very simple query. We are not talking about a complex query. But when it comes to a query, for example, which requires multiple stages of processing, it requires, let's say, data to be printed or dumped into a user terminal or a user screen, or for example, there is a join required or order by clauses there, or some kind of predicate has to be applied, then obviously those stages also add up to the overall time. So there is not going to be 200x benefit, but theoretically we can see that if the same work can be divided among 200 workers, then the overall time that is required to complete the job gives you a great scale. Right? So this is the basic idea behind parallelization. Let us talk about the same thing. So let's say 20 seconds for all the splits, it gives you the same time instead of 4,000 seconds. It is possible if sufficient resources are available to run all these splits at the same time. So first of all, the problem is that you need to be able to scale according to your query requirements. So in this example, because the data size is 20 GB and let's say we are dividing it into 200 different splits. So it needs to be it needs to be possible that those 200 splits can be assigned to you automatically and instantly, so that the query can be divided into those 200 splits and then you can move on. Now the problem comes that in a traditional system, this compute requirement would not be assigned to you dynamically, it would be assigned to you statically. So even if you are not using this compute powers, you are going to be billed for it just because it has been assigned to you, it has been allocated for you. But a modern engine would allow you to use this processing power only when it is being actually required. That is why, that is how it is going to be able to reduce your cost of computation. Then there needs to be a central orchestrator, or there needs to be a central cluster manager, to say, which is required to harmonize the different operations, whether it is scanning of the work or scanning of the records from the data sources, whether it is division of work, aggregation of results, moving of data from one stage to the another, and so on. Let us see how it is done over there. So let's consider a typical query in which there are two tables, customers and orders. And there is a need to inner join the tables based upon the common order ID or customer ID field. Sorry. And once the data is being selected from the data sets, that data needs to be joined, then it needs to be grouped by, let's say, based upon customer category or some other criteria. And finally, it needs to be presented to the analyst by ordering it into different things. So you can see that there are different stages going on from the bottom at which we have the different data sources and going on altogether, right? So the scan stages are executed first, and the select on both the input tables, that is orders and the customers, are done simultaneously in parallel, and this processing is completed in parallel. So instead of having a single compute engine scan the data and to feed the pipeline, multiple engines, multiple workers, multiple cores are going to scan the data, and they are going to feed the pipeline. That is going to go there. Then at the joining stage, once the data has been shuffled in the sense it is moving from one worker to another worker for joining. So once again, the data gets joined at the join stage, and this is also being done in parallel, right? So the number of workers at this stage, or the extent of parallelization at this stage, would reduce dramatically, but still it would be way higher than the single core that we are typically using. Once this is done, the grouping would start happening, and once again, the amount of data that is going to be grouped, the number of workers that is required at this stage would again reduce. The reason that the number of workers are reducing at each stage is because we are now aggregating the results. And if there is any predicate that needs to be applied, for example, there is a where clause or a having clause, then it is going to pare down the data that is being transferred from one stage to the another stage. So for example, in the scan stage itself, if we have a where clause and this predicate is pushed down this stage, instead of applying the predicate at the top stage or somewhere in the middle, if that particular predicate is pushed down and it is applied at the bottom of the stage, then automatically it is going to optimize your query. Why? Because instead of processing all the 20 GB of data, after applying, let's say, the where clause, we are going to use only, let's say, 10 GB of data or 5 GB of data for only the records which meet the criteria defined in the where clause, and so on. Once again, once the groups have been formed, while the groups are being formed in the third stage, you can apply the having by clause. And once again, the predicate has been pushed down to the extent possible. And it is going to reduce the number of records that go from the second last stage to the last stage, that is the order by stage. So multiple things can happen, and these things can optimize your overall cost. These things can not only optimize your overall cost, but also speed up the query processing time. All right. So any questions so far related to MPP query engine? You can give me a thumbs up in the chat box. All right, great. Yes, the order in which a query is processed is very, very important. And there are few things that the analyst can take care of. That is the person who is giving the query, who can take care of. But there are many things that the query engine needs to take care of. For example, if I write a simple query, for example, the query is select star from. Generally, we shouldn't give a star query, but for the sake of simplicity, let's assume that the query is select star from customers in a join orders on customer ID equals to order ID, and where customer category equals to platinum. Now order by customer ID. Now let's say this is my query. In this case, in this query, as the user of this data or the analyst, I do not have much choice except for not using the star and specifying the specific columns that I want to use to optimize the query. But the query engine can do one thing. For example, instead of applying the where clause at the end of the query, it can apply the where clause at the beginning of the query. So instead of applying it at the top in the order stage, it can apply the where clause. It can push down the predicate, this processing tree. It can push down the predicate, this processing tree at the bottom. And before passing on the data from the data source to the next stage where it is being joined, it can actually see if that particular record matches the criteria. If it matches the criteria, it passes it on to the next stage. Otherwise, that data is never passed on to the next stage. If the amount of data that is being passed on to the next stage reduces, then obviously your query processing would happen much faster. Does it make sense? All right, good. Any more questions till this point? Okay, thank you. Let's move on. Now, let us understand the structure of Trino query engine. So Trino is the query engine that is trusted by industry leaders at petabyte scale. We are not talking about terabytes. We are talking about petabytes. For example, Netflix processes 25 petabytes on S3 buckets. Facebook is processing 300 petabytes of data in their data lake. Lyft is processing 10 petabytes of daily read data, as well as they are processing more than 250,000 queries per day, and so on. So the figures are there for all of you to see. If you want to see, then there is a client and there is a coordinator, that is the central orchestrator that I was talking about, who needs to coordinate everything. The client and the data sources, they work with this coordinator. They do not have any idea about how the workers are working. This coordinator manages these workers. This coordinator manages the data sources, and this coordinator is providing you the shell or the interface through which you submit your queries and you get the results that are required of you. So, for example, I'm the client, I'm the data analyst. I'm going to submit my query, select star from customers in a join orders on customer.customer ID equals to order.customer ID, where customer category equals to platinum, order by customer ID. This is my query which I want to submit. And that query is submitted to the parser and analyzer. Suppose that I have the requisite permissions, I have the requisite privileges to access the data. That data goes on to the query planner and the query scheduler. Now, the query planner and query scheduler are two interesting tools. The query planner identifies where and which indexes can be used. The query planner can identify which section of my query, which part of my query needs to be executed first, and so on. The query scheduler is the tool or is the component of the coordinator, the Trino coordinator, that divides the work among workers. So this scheduler is going to instruct the workers that, okay, now you need to start reading the data from these data from this data source or from multiple data sources, depending upon whether your query is from a single data source or from multiple data sources. They will start reading the query, processing the query, and they will continue to pass on the query results to the next stage. There is no storage apart from the intermediate cache. There is no persistent storage in this Trino cluster. So there is no persistent storage. We need to understand this. But whatever you need to store, that needs to get stored finally on one of the data sources, the data lake or the data lake house that you are using. There is no storage in Starburst or Trino. Okay, so that data keeps on passing through different stages, and until you get the final data that starts coming to the parser and analyzer, and that once again starts giving the data to the client. Now, this client can be a human user interacting with Trino through its CLI. This human user can be interacting through a web UI. For example, we are going to see the demonstration of Starburst Galaxy. It can be a business analytics or data analytics tool. It can be any tool which is going to fire the query to fetch the data, to receive the data, and to present it to the final user. Right? Now, when it comes to Trino, why don't we use Trino directly? Why do we need to use Starburst? Trino is great, Trino is efficient, and Trino is something on which Starburst data, the Starburst platform is completely built upon. So why do we need Starburst? Why don't we simply stick to Trino? It is open source, so why do we need to pay for using Starburst services? The problem is that Trino does not come without its own challenges. So the first and the biggest challenge is that everything is manual. There is no possibility of auto scaling. So if you need to scale, for example, continuing with the previous example that we discussed, if you need to scale from one worker and you need to scale to 200 workers, everything needs to be configured in the commands that you give to people. There is no built-in security integration with Trino. So there is once a client connects with the Trino CLI shell, it does not take into consideration whether the user has requisite permissions or not. There is no identity access management. There is no role-based access privilege policies and so on. So those problems are there. Now, it requires third parties for role-based access control. There is no access control for data. And third-party integration is not very, up to the point or up to the speed when it comes to RBAC requirements. Finally, there is no support team. The community is still growing. The community is still working on it, but there is no dedicated support team. And if the community does not respond to your problems, if it is a critical problem, then you are left in lurch and there is no problem. And all of these things require a considerable amount of money and time to be invested by the adopters of Trino when it comes to an engine, right? Now, when it comes to Starburst, it not only provides you the facilities, the benefits that Trino offers, it adds on its own additional benefits. For example, it supports all the open file and table formats. It runs on commodity cloud storage and compute. So the total cost of ownership comes down to nearly 50%. You can query the data at source when it is required. It is 90% faster time to insight, 10 times faster query speeds are there. Minded, Starburst is not basically designed for mission critical real-time analytics, but when it comes to, because it does not have any storage, as I mentioned earlier, the Trino cluster does not have any storage of its own. So whenever the data is being processed, whenever there is a materialized view, whenever there is some data that is needs to be analyzed, it directly comes from the data source every time you run the query, right? So like other pipelines or other analytics tools, there is no internal storage in Trino for persistent purposes, and that is why it is an analytics platform. It is not, it is a pipeline, but it does not provide its own storage. But if you are talking about queries which are not mission critical, in which some sort of delay, for an example of a few minutes, is allowable, in that case, the query processing speed is not only fast, because you are combining the data from multiple sources and directly from all the sources. You don't need to run the query separately manually on different sources, the legacy systems. The overall query execution speed is much more faster. And more importantly, your total cost of ownership reduces to a great deal. Then there is a single governance and security layer for all the data. You do not need to integrate third-party tool for role-based access control or for implementing IAM policies and other security aspects of for the data. And more importantly, you can create data products and you can allow your users of the data to take ownership of the data products and to allow global search of those data products. So we are going to see all these things when it comes to the demonstration of Starburst in a few minutes. So if you have any questions, please do let me know. Give me a thumbs up if we are good to go. Okay, great. Thank you. So when we talk about Starburst, we are talking about a galaxy of tools, as you can see from here. So there is a single point of access as well as query federation when it comes to looking past the data lake. So Starburst has a central analytics engine. Starburst provides you global security. And as you can see, it runs on MPP query engine, that is the Trino. It offers you data products. It offers you fault tolerant execution facilities. There is a query optimizer. There is elastic auto scaling, which all these features, which as I discussed, are not available in the Trino MPP query engine. It offers you smart indexing and caching. Then there is metrics and logging, which can help you optimize your storage and analytics needs as well as querying needs. When it comes to global security, there is end-to-end encryption, data masking, query auditing, and access control. And as you can see, that there is a great deal of client support. There is a great deal of business intelligence integration, and you can connect to almost every data source. The keyword here is optionality. Starburst does not force you to choose between one data source and another. It does not force you to let go of your legacy systems or to process the data from that legacy system from using some other technology. It allows you to access the same legacy system to be queried using the same SQL that you already know. You do not need to go to any other tool to access the system. If the legacy system or the system that we want to connect to this data pipeline can be accessed or can be queried using SQL. It supports standard SQL. So it means whatever skills you have learned from SQL course or your practice, they are not going to go to waste, and they are the actual tools that the skill set that you require to start working with Starburst, which we are going to see in a moment's time later. When it comes to BI integration, not only Starburst allows you analytics facilities within its own query editors, but you can integrate it with the modern GUI BI tools such as Looker, Power BI, Tableau, and so on. And these tools can directly query the data using the Starburst as their data pipeline or analytics platform. And once that data becomes available to these tools, they can start giving you dynamic and real-time dashboards. And when it comes to client support, you can see that Starburst has integration with dbt, Airflow, Python, Jupyter, R, Spark, JDBC, ODBC, and so on. So connectors based upon these different tools are vast and varied, and can connect to virtually almost every data source that is available out there. Right. Now, once again, coming to the execution architecture that we saw with Trino. So in place of Trino, you have the Starburst in between, which is your client, and you can see that there is a rich ecosystem of data sources connectors, and there is the tools that are there. Okay. Now let's move on to demo. I'll stop sharing for a while, and I'll start the sharing of my demonstrations in just a minute. Okay, so this is my Starburst Galaxy, which has been spun up for DataCouch, the company that I'm working with. So this is datacouch.galaxy.starburst. So if you are already a client of Starburst, then it would be, instead of DataCouch, it would be your company name.galaxy.starburst. Galaxy is the on-cloud tool that is there for you. So I have my credentials saved in. Let me sign into Starburst Galaxy. Before moving on to the execution of the queries, let us first of all explore the environment. So first of all, let us talk about clusters. So as you can see that two clusters are already available. One is AWS US East free. There is Query Plan Labs. These are the clusters that are available to us. We can create new clusters. So let us create a new cluster. Meetup demo. Let's give it a name, Meetup demo. What catalogs I want to connect with this cluster? So I can connect as many catalogs. So let's talk about catalogs and clusters. A cluster is a set of compute services that are there, and catalogs are the data sources that have been connected by you. So I'm querying instead connecting with these many catalogs. If you want, you can remove any of these catalogs, and those catalogs would be connected with your cluster. They would be associated with your cluster. So because we are using right now the free cluster services, so it is only allowing us US East North Virginia. But as you can start taking the advantage of this Starburst Galaxy, right now we are using the AWS services as at the backend for compute as well as storage services. But you can run a query that is federated across multiple cloud service providers, multiple data lakes. So for example, your cluster might be running on AWS and your data would be coming from an Azure cloud or a Google object storage. And it can process the data even from those or from legacy on-prem systems if you have these specific connectors and if those systems are online with you right now. Now, I can make a standard cluster or I can make a fault tolerant cluster. We'll see about that. So instead of a free cluster, let us choose a small cluster. The moment I have a small cluster, and you can see the fault tolerant facility becomes available to me, which was not available with the free cluster. So what is the difference between standard and fault tolerant? As the name suggests, a standard cluster, the query may fail and you may need to restart the query. But in case of a fault tolerance cluster, the cache size that is available to the cluster is far more as compared to a standard cluster. And that is why even if some of the workers might fail, other workers might take on from them from the point where they failed, or This failure may not only be because of workers, but it may also be because that some data source might have lost its connection and so on. So we can go for that. But right now, because we are not interested in going for fault tolerant queries, we are only interested in getting a demonstration of the system. So we are going for a simple free cluster, right? With this particular time, you can actually save on the cost, because that is the time for which your cluster is going to remain available, and that is the time you are going to get billed for. So in a production environment, it is generally never suspend the cluster, but when you are debugging, when you are developing, and especially when you are playing around and exploring the system, you can have a 5-minute or 15-minute suspension time. So what kind of roles you want to assign? Those roles have already been defined. For example, there can be an HR user. So HR users can create their own data products and publish them, so that employees in the organization can get to know about their own, let's say, leave applications or leave balance and so on. There is marketing related role available in this demonstration, and so on. So when we talk about public, so any authorized user can do it, or students, right? So let us go and create the cluster. It is going to start the cluster. It is going to take some time. So while it is starting, let us go and check out the catalogs that are available. So as you can see that these are the catalogs that are available to us. Right now, these catalogs are available in any of the clusters that we are going to spin up. But let us check out the catalogs that are available. Let me just expand a few of them. So as you can see, if you check out this particular catalog, so you will see that there are 17 schemas or 17 different data sets within them. So let us check out the employee schema. Within the employee schema, you have different tables that are available. So for example, there is a departments table that is available. And in the departments table, there are 2 columns or 2 fields, that is department number and department name, right? And you can check out the employee table also, and there would be a few fields for that: employee number, birthday, first name, last name, gender, hire date, and so on, right? So you can check out the schema discovery. So if you want to run schema discovery, you can run the schema discovery, and it is going to look for new schemas that has been added to the lakehouse since you last ran the discovery, and they will be updated for you. So even if new users or even if different users start adding different schemas to the catalog, it is never required by you to do it manually. You can run schema discovery every few times, let's say once a week or a couple of times a week. And whenever there is a new schema added, nobody needs to publish it or to announce it in a blog post or in a company channel and so on. And you simply run schema discovery, you find that new schemas are available, and you start working with them directly. Then there are metrics, which gives you information about how the data catalog is being processed, how it is being used, and it can help you actually optimize your access of the data catalog. So what are the top users? And because this is a new spin up that we created specifically for this meetup demonstration, so you can see that there is no data to display right now, but top sources and top queries. And once we run a few queries, we are going to come back to this thing, and we are going to see that top tables, top queries which have been queried, what are they? And it is going to give us more information about it. Then you can see there is no query history. If there is an audit log of all the changes done, of all the things done, that is there. And then finally, privileges are there, that what roles and what users have the privilege. So for example, I have the account admin role, and that has the ownership of this particular schema. All right. After clusters, let us check now. My meetup cluster is available, and if I want to run some query, so this is my meetup cluster. To run any query, I'll simply choose the cluster. Just please, I'm so sorry. So let us choose Lakehouse. Within Lakehouse, let us choose employees. And now you can see that there are 3 dots available, which was not available earlier when you were looking at the catalogs. And once you click on these 3 dots, it can create copy full path to the clipboard, select schema query, enter the show create schema table and view details. So let us click on this select schema. And as you can see, I'm not writing any SQL as of now. This is deliberate because I want to demonstrate that even if the user is not very much comfortable writing queries, the GUI environment itself gives you facility to write queries to start to give you a kickstart, to give you a springboard on which you start working with your data sets, you become comfortable, and then you can start working with SQL as you move ahead. So when I click upon employee, I see enter select from employees limit 10. I see this query and I run it. Now, because the cluster is already spun up, it is going to execute quite fast. Let us see. So these are the 10 records. Select start from Lakehouse employees limit 10. So all the columns from the employee table have been there. If I want to check a specific thing, then I can check the query details also. So I'll click on this I button and it is going to take me to the query history and to the query details. It is going to tell me what the query is, what is the basic information about this query, who processed it, what was the role, what was the client, how much CPU time was required, what was the elapsed time, and what is the query execution path. So query was submitted at this particular timestamp. Then there was queuing, there was analyzing, there was waiting for resources. Once that was done, it was query planning, query execution, and it completed within 61 seconds. If I want to check out more details, I can see the full query text and it gives me like this, if the query is quite large enough, right? So that is how I can go about it. If I click on advanced, you can see it is also giving me the execution query plan, that at what stage, what was done. So this query was executed in 2 fragments, right? So it is telling you that this query was executed, and because it was limit partial, there was a table scan. Once the table scan was completed, it was because limit partial, it was there. It told you about what the columns it was scanning. So it scanned the gender, employee number, birth date, last date, hire date, and so on. So all those information is available. Because we are right now not getting into the details, I'm just going to close this one. And you can also check out the stages. So there are 2 stages which were there, as we just saw in the advanced query plan. And you can also check out the query execution graph. And as you can see, if I take my mouse on any of these things, it is going to give you the details that what happened at what particular stage. All right. Yes. Yes, certainly. We are going to run a few queries which are much more complex than this one. It is only a demonstration. We are just starting with it. So we are going to run a few more complex queries, and in which we are going to see how these query stages differ from this simple graph that is there. Yes. It will be in a moment. Sure. Okay. Now let's go back to the query editor. Okay. Now in the employees table, let us check the describe employees and let us see how it gives. So it is going to describe the table to me. Any additional constraints are there, any comments are there, what are the table types and so on. A simple thing that I believe most of you understand. If I want to see the show create table also, then it can give me the create table statement also of this particular table. That what is this? So as you can see that it is using the format ORC and the table type is high, right? So the file format is ORC and the table type is high, that is there. And this is the create table. This is the by default structure of a query that is created with Starburst. All right. Now let us see if I can work with these queries or not. So in this query editor, the query which I just created, I can double click on this and I can save this query as meetup demo, and this will be saved. It will go into my saved queries. And if I want to refresh this thing, it goes into there. So let us see some saved queries. So I can create a new schema also. I can use this schema and then I can copy the data from multiple tables also, right? So these are some of the queries that are there. We are going to describe these queries as we run them one by one, and then we are going to work with it. So let us create a schema called Mudit. The database is, or the catalog that is there is TPCH. Within Tiny, it will create a schema called Mudit. I need to refresh it. Okay, this it is actually starting the server because I was using the meetup demos cluster. It is starting up the server that is AWS. Okay, catalog TPCH only has the read-only access. Okay, no worries. So let us do that over there. Within the lakehouse, let us run. So because there was no error, it simply said finished. Now let us use Mudit. So it is going to use Mudit and the schema would change to Mudit. Now let us see if I have the within the sample catalog, do I have the demo, and within that do I have the sample? And why I'm using this, because I'm going to run a few queries on this. So I'm just want to show that whatever SQL you already learn, you already know, you can create data from that. And we'll start with a simple select query, which is CTAS, create table form using a select. All right. So within this demo, we have astronauts table, and we are going to use that. Okay. Then there is another create table for missions. Now it is going to create multiple tables. So instead of that, let us first of all query my own tables that I have created in my TPCH schema. This is my schema. And you can see that the astronaut and mission tables have gone from this sample schema, sorry, the TPCH schema to this lakehouse, right? Now, if I want, I can run any query on this. For example, select star from astronauts, limit 100. So it is going to give me the names of the astronauts in specific details, all the columns that are there for this. Right. Let us run a query for the missions table. Total missions, the space missions that have been run so far, right? So there are only 100 records there, although there are total 184 records, but we have selected only the first 100 records. So we have the mission ID and we have the status of the mission, right? Now let us run once again the astronaut query. So it is giving you the mission number, mission ID, and let us run a simple join query based upon this mission number, right? So if I want to describe the missions table, in the astronaut table, there is the mission number field, and in the missions table, there is the ID number field. So we need to remember, we need to join based upon that. Select C. And m dot date. So in this query, we are simply identifying the astronauts. We are going to identify the name of the astronaut, the company, the agency basically, whether it is NASA, ISRO of India, whether it is SpaceX, or whether it is Virgin Atlantic or any other company which has launched that mission. What is the status of the mission? Which date was there? And the join would be there. So let us also describe the astronauts table. So, and instead of running the describe command, you can actually check it out over here. So that you do not keep on changing the output window, right? So you have the ID. So I have the astronaut ID, I have the astronaut name, I have the mission company, and the common field that is there is mission number and mission ID, right? So based upon that, sorry. So based upon that, I have joined these two tables, and now I can apply a where clause as well, where let's say where the nationality, let's say national, or instead of nationality, let us say status mission, m dot status mission equals to, now we have to find the specific value. So let us run this query once to check out the different values that are there. So status mission is equals to success. Order by m dot date descending limit. Okay, so this is my query, right? Let us run this query. Okay, there is a spelling mistake, I suppose. Yeah, sorry, I'm so sorry about that. Okay. M dot ID. Okay. I'm very sorry about the glitches over there. So as you can see that the mission ID is 1228. Sorry, the astronaut ID is 1228. The astronaut name is Ivanishin Anatoly. The company name is SpaceX, and the mission was a success, and it was launched in 2020. So that is the data that is there. Since then, many missions have been launched, but this data was probably updated in 2020, and that is there. So if I increase this to 100, and I'm going to run it once again. And why I'm doing this, I'm just going to show you the query execution plan in this. So I go and see the query details over there. So this is how the execution gets done. If you go and check out the plan over there, and if you want to look at it in detail, so you can see that multiple stages are there. So fragment 2 is there, then fragment 1 is there, and then fragment 0 is there. So basically fragment 2 is your scanning stage that is happening. It is processing the data, it is pushing down the predicate and all those things. And as you can see that scan filter project, local exchange is happening, inner join is happening. So all those things you can see while you are doing a course on optimizing data lakehouses with Starburst. And if you want to check out the stages, you can check the graph, and you can view the graph in a full screen mode as well. So first of all, you scanned the data. The total CPU time that was required was 14.5 milliseconds. It was buffered, query splits, and so on. Then there is a scan filter project. It takes this filter data, and local exchange of data was happening. And then the inner join applied, then top and partial data, because I applied the limit 100 thing. The stage 1 finished, and then finally the data was displayed to us in this thing. All right. So this is how the graph formulates. Going back to the query editor. Let us check out the saved queries. Now, not taking much of your time, I'm just going to show you a federated query. And this federated query runs on the AWS cluster, the free cluster on Lakehouse. Now you can see that in this cluster, there are multiple catalogs which are connected to different data sources. So there is a Lakehouse that is hosted on AWS. Then there is a TPCH server, which is basically a status server in which the data has been there for analytical purposes, for optimization purposes. And there is a PostgreSQL server on which the TPCH data is also there, right? So multiple data sources are there. I'm just going to run this query for you, and we are just going to see how this query from different sources, how Starburst can combine the data from these multiple sources and run for you from the same source. And just for your information, that the Postgres server that is available in this particular query, it is an on-prem server which is connected via dedicated connection to the Starburst data pipeline. Right? So it is going to be a very simple query that we run over there. Yes. Okay. So I'll show you multi-table join also. Yeah, just. So in this particular case, the query was that the orders data, the customer data, and the nationality data was keyed in. And we wanted to analyze how much the data from each nationality came in from customers. So customers can belong to multiple nations in this particular database, and how many orders from each country came in. So as you can see, that number of customers wise, France was the country that contributed more to the most number of orders at 61,600. Then Russia contributed 61,500 approximately, Indonesia at 61,400 approximately, and so on. And at the bottom, we have, say, Saudi Arabia at 58,000 orders, and so on. Right? Now, if I want to check out the query details, yes. Okay. Yes, sure. Let me just show you the graph, and then we'll come to that. Yes, sure. So as you can see that this particular query required 5 stages to finish. Let us check out the graph, and let us check out the graph in full screen now. So let me zoom in. on the graph. Okay. So there were multiple processors workers involved, and it required almost 211 milliseconds to complete the scanning part. Then after this scanning, 752 bytes of data per rows was transferred to this thing. Then there was inner join that was happening. Then projection happened. Then stage 4 finished, and this data was there. And some data which was coming in from the nation table, because nation table was accessed only once. It was to be the first stage of query combined actually the orders and the customers data. And once the order and customer data were available in a joint format, then it was joined with the nation table to get the number of customers from each nation. And that is why you can see that there are multiple stages going on like this. All right. So we can check out that our queries are executed in a staged manner, and we are actually using the number of how many number of processors are being used, how many parallelism is there. So 35% is basically the rate of parallelism. The total time that required this query to elapse was only 13 seconds. The CPU time was actually 4.7 seconds only. How many rows were read from the data sources? It was 1.8 million rows. The bytes per read was 4.7 megabyte of data was raw. And the peak memory usage was only 14.5. All right. So you get all these kind of information insights into the execution details of your query. Right. Now, let us go back to the query editor and let us explore one of the most interesting aspects of Starburst Galaxy that I find very exciting. And why I find it exciting is because that once you create a data product, I'm talking about data products, once you create a data product, it does not have to be basically something that only a techie can access. So as we saw that while we were creating a new cluster, while we were spinning up a new cluster, we saw that there are different roles which are related to our data pipeline. So there was an HR role, there was a marketing role. So for example, I create this setup of data pipeline using Starburst for my organization. I'm part of the central data engineering team, which is taking care of all the plumbing, which is whether it is related to connectors, whether it is related to data sources and so on. So let me first create a data product for you. I have this query, I have this insight with me. Now I want to share this insight. I want to make this insight available to anybody. The data would keep on coming. It's not static because this is a demo database. Every time you run the query, you are going to get the same number. But in a real world scenario, the data would keep on adding to the system. So if I create a data product out of it, I just need to, I want to add to an existing product, or I want to create a new product from this query. So I want to create a new product. I click on this next. Let me identify the lake house, and or let me identify lake house and where this schema is going to be. So I need to provide a schema name. So let us call it meetup demo analytics and use the default schema location. So select the data product location. Now I want to give it nationality, customers by customers by nationality. So I need to provide a number of customers from different countries ordering from us. Sorry for the spelling mistakes. Thank you everyone for joining. There are many questions. I'm trying to answer as many as possible. Yeah. Okay. So let me just quickly go with the data product. You can provide a description that the users of your data product or the consumers of your data product are going to see. And you can create a dummy link for that actually. So let me just give you the dummy link and the slug, both of them. So customers by nationality, and let me create a slug also for this. Now, the problem with this slug is going to be that it is not going to be working as of now, because right now I'm going to simply use this URL at the beginning. And because I do not have access to Starburst IO domain, it is not going to work. But if I give the domain for my organization, if I give a custom domain for my organization, then you can see that it is going to work. And you can add multiple links also to it, right? And who are the contacts for it is going to use. So let me add Bhavuk for this, and let me add Aman and Harshit for this. So these are the contacts who are going to get information about this newly created data product. Okay. So I save and continue. And this is the preview data set. Whether I want to save it as a table. If I choose a table, then it is going to consume storage resources, and storage is going to cost you. That depends completely upon the plan that you go for. Or I can choose it as a view. The benefit of a table is, as you understand, that the query time, the query execution time would be far, far less, but it is not going to get updated automatically. So you need to run the data, update the data from time to time. But the benefit of the view is, even if the data keeps on getting updated, keeps on getting added to the data sources, the different data sources that we are connecting to, it is going to get reflected every time the view is going to get executed, right? But it is going to be compute intensive every time you are going to execute it, because if the data is continuously adding to the data lake, then the view needs to be refreshed every time. So you need to trade off between efficiency as well as recency of data. So if you understand that the updates are not very frequent, or they come in batches, or they come in very infrequently, then you can go for the table, and then you can update it when there is no peak hour or in the background, whenever your system is less low. Or if you understand that the data keeps on updating very frequently and the users need to have real-time insights, then you can go for a view, right? And if I want, I can give a data set name also. So I give it the name meetup data. So I create a view instead of table. So meetup demo has been created. Now let us check out. So this is customers by nationality. If I click on this view details, it will give me this thing. And this is the link that has been created. And as I told you earlier, this link is not going to work, but let me just show it to you over there. So this is how the link is going to be there, because I do not have the access to the Galaxy or Starburst domain name servers. It is not going to work. But obviously, as you can see, that this can work anywhere. So instead of having datacouch.galaxy.starburst, it can be simply datacouch.io/customers by nationality if I have access to this particular page. And it will get the output of that particular data set is going to be available for my customers to view directly. This is how simple the work can be. Now, to conclude, I must just give you a preview of the connectors that are there. So if you want to check all categories, you can check out all categories. If you want to, let's say, connect with Looker. So this is the cluster information that is there. And this is the information for user. This is the information for the host. And this is the port number. You need only this much details to connect with Looker for your business intelligence requirements, right? If you want to go for data integration using DBT, this is the entire information that you are going to require. So you can connect to a partner if you have an account with DBT for data integration, or you can use a connection file, download the connection file and upload it to your DBT interface, and it is going to work with that. Whether it is drivers or clients, the latest update has been integration of Python libraries with Starburst, that is PyStarburst, and that is going to be there. So once again, you require only this much information to start using Python data frame API with your Starburst. So if you want to check out all partners, those partners are being listed over here. You can check out those partners. And if you find that your specific partner is not available, you can reach out to Starburst team. And it is quite likely that either with the help of ODBC or JDBC or Trino Python or Trino CLI, you would be able to connect with them anytime. Now, just to give you a glimpse of how the admin part is there, so you can check out the audit log. So you can see that I have created a data product, and there was a suspend state of this particular cluster. I enabled it. I created a meetup demo cluster. I enabled it. Then cluster configurations are provided there. So if I want to create some kind of peak hour scheduling, that I can do that over there. If there is a billing information that you want to control, so you can see that my company's billing information is over here. Usage information is given there, that which users have been using. So month to date, because this is a new cluster, which has been spun up only for this particular thing. So you can see that this cluster is being used for last 1 hour and 2 minutes. The meetup demo, since its creation, has been in the use for 33 minutes and so on. If you want to update the admin users of your data engineering team that the cluster usage is going beyond a particular limit to control the cost, to check out the issues and so on, you can set up different notifications. Let us check out the access control. So these are the different users that are there, and these users are, or as you can see, most of them are DataCouch users. These are the different roles and privileges that are available. So all these things I'm just showing to you so that you can become familiarized with the environment, and when you start using Starburst Galaxy, it becomes, yes. Sure, I'll just go to that catalog and I'll show you the usage details of that. Just you can set up your single sign-on facility with your company's integration. So as you can see that there is datacouch.galaxy.starburst.io. So if, for example, let's say you're working with Walmart, so it can be walmart.galaxy.starburst.io, and with a single sign-on using Walmart's credentials, you can connect with your Galaxy account. Then auth tokens are available. Service accounts are available that you can use for testing and other purposes. Then there are tags which you can create, and once you create tags, you can start using those tags in your clusters, in your queries, in your data products, and those tags are going to provide you better indexing and those services. Let us check out the cloud services. So right now, for publicly hosted this thing, Starburst Galaxy is available for AWS, Azure, and GCP. That covers almost 99% of the market. But if you want to implement Starburst Enterprise or Starburst Galaxy on any other cloud, whether let's say it's Alibaba Cloud or your company's private cloud, then that is also possible. So for that, you need to connect with Starburst support team. Yes, Ramakrishna, which features are we talking about?
Hi.
AI features. Okay.
Am I audible?
Yeah.
Audible?
Yes. So,
oh,
yes,
okay,
yes, you are audible.
See, now it's all about like kind of ChatGPT or AI features made available in any product, correct? So
yes,
like that, anything is included within this product?
Okay. Probably I might not have been able to communicate this. Starburst is basically providing you the data pipeline, as well as Starburst is providing you an analytics platform, which is based upon SQL. So it is possible that you integrate Starburst with ChatGPT or those kind of generative AI tools, and instead of typing in queries, you can type in prompts and get this thing done. We have been communicated by Starburst that they are working on some kind of generative AI integration with their platform. Right now, it's not available as of now, but they are working on it, and quite likely it is going to be rolled out very soon. And if we are talking, and if we are talking about any of the front-end tools, for example, BI tools, whether it is Looker, Tableau, or Power BI. So let's say Power BI is already offering OpenAI's ChatGPT services with its Office 365 and enterprise licenses. So you can use those prompts-based generative AI tools with Power BI, which is going to probably connect with Starburst through its connector and going to run the query for you. So it can be done that way also.
In the sense, I can give natural language and it will form a query.
To Power BI. So once the connection is established, Power BI is going to translate your natural language prompts into SQL queries appropriate for Starburst. And it is going to use Starburst as its data lakes analytics platform, DLAP. Starburst pipeline is going to connect the data from multiple sources. So those sources are going to, as we saw, the queries are going to get executed. The results would be delivered to Power BI backend, and Power BI service is going to deliver you the results in the form of dashboards or reports that you want.
Okay, for that is a feature not by
in
the
Power BI as of now, not in Starburst as yet.
Hmm.
It's a feature that is being tested internally right now. It is not available publicly.
Okay. Is there any place I can see more details? I'm interested to know that. That's why. Is there any
about Starburst?
No, about this Power BI, because I'm using heavily Power BI. So is there any place I can?
You can drop in an email to our email ID, that is support@datacouch.io or info@datacouch.io, and we would be more than happy to respond to that. Or you can leave a comment on the YouTube video. This stream would be available on YouTube, so you can leave a comment over there, and our team can reach out to you later.
Okay. All right. Thank you.
Well, so right now, because we are using AWS. So you can see that I can configure the IAM roles, I can configure the SSH nulls. I'm not going into the AWS part of the details or the Azure or GCP part of the details, because that is something that completely depends upon an organization's choice of the vendor. And Starburst is more than happy to help, or DataCouch is more than happy to help clients to get onboarded with Starburst, as well as their choice of vendor for cloud or data lake services. So that migration or that facility can be done away when you are reaching out for a support for that. All right. Now, let us once again go to the Lakehouse, and we were talking about that if we can check out the Lakehouse related statistics that I discussed at the beginning, right? So I click over there and I see, let's try some metrics. So you can see the dashboard is already giving you some information about the metrics, that Mudit has run these 13 queries. It has run queries on Galaxy, and it has run queries on Galaxy Explorer. One query on, now this one query on Galaxy Explorer is related to the data product that I created, right? And this is running Galaxy. That is the query editor that I was using to run my queries, right? So astronaut table has 5 queries, mission table has 5 queries, then nation table has 2 queries, employee has 1 query, and the meetup demo has 1 query, and so on. So you can see the query history. What are the queries that I ran? So these are the top latest 10 queries that are there. Audit log is also now filled up. It will take some time. Yeah. So permissions are there. So as you can see that all these metrics are going to help you, and as more and more users start connecting, start using your data pipeline, start using the analytics which are supported by Starburst, these metrics are going to be available, and you can check out these metrics in more details also. Starburst is always going to be there to support you with more metrics, which are going to help you optimize your requirements. All right. So that is the glimpse of the Starburst Galaxy environment from our side. If you have any more questions, please feel free to ask. You can type in your questions in chat, or you can type in your questions. You can unmute yourself. You can ask the moderator to unmute yourself by raising hand. Okay, great. And this video recording would be available on our YouTube channel. So let me go back to my presentation. So you can check out this video recording on our YouTube channel. You can, as I requested Ramkrishna, you can check out our company profile on LinkedIn. You can reach out to us for any queries related to any tools or training services or any technologies that we are dealing in. Or even if we are not dealing in, we can customize those trainings for your specific requirements. So you can reach out to us on our LinkedIn page, and you can check out our YouTube channel and other services. So thank you for giving us your time, and have a great journey with Starburst.
Thank you.
My associate Harshit has pasted the LinkedIn profile in chat for everyone. If you want to check out, that is available in your chat. So have a great day and happy. Thank you.